Welcome back, everyone. We are in the final session, and in this session, we will have brief remarks from science agency and policy leaders from Europe, the United States, and Mexico. And it will be moderated by Dr. Tom Richard, who is the director for the Institute for Energy and the Environment at Penn State University and a great colleague.
Thank you, Greg. It is an honor and a privilege to join you for this summit and to moderate this session. I have the pleasure of helping to coordinate and support interdisciplinary research on energy and the environment at Penn State University. It gives me great pleasure to engage the faculty of our university, where we have a particular focus on stakeholder-driven research and high-impact research. And the AIR Center is exactly the kind of program that we want to support. So I'm very glad that we've had a role in this summit, and I look forward to working with all of you in many programs in the years to come. I especially want to thank the AIR Center and its leadership for organizing this dialogue, and to all the center's many partners, including those who we've heard from today. There's just a lot of great information that's been shared, and I'm looking forward to the remaining sessions over the next few days as well. As many of the speakers have noted, this is a time when we are especially aware that global challenges require cooperation and coordination. This is a time of both challenge and opportunity for the blue economy, and the AIR Center mission themes can each contribute to both resilience and advancing the blue economy of the Atlantic in the years to come. This final session of the day will focus on a particularly pressing question: how space and ocean sciences can support economic recovery and job creation in a post-pandemic world. While a global response is clearly needed, this must also be supported by local action at the national and agency levels. We are privileged to hear next from leaders of some of the premier science agencies focused on oceans, the atmosphere, and space. To lead off this section, Miguel Mora, the CEO of the AIR Center, is going to provide a brief introduction.
Thank you very much. Thank you very much, Tom. Well, during the year 2020, all societies of the world have suffered in a ruthless way the scourge of the COVID-19 pandemic. We know that the world will not go back to be the way it was before, but now it is up to us to design how we want to recover from this terrible event. Our recovery must be guided towards a more supportive, resilient, and knowledge-based society. This titanic task of recovery should not allow this pandemic to eclipse the great challenges our society faced and still faces in recent years: climate change, the scarcity of natural resources, the acidification of oceans, or the biodiversity loss. Rather, on the contrary, we must fight for a more just, solidary, and healthy society, providing solutions to all those challenges. Those solutions must be established on technology and scientific knowledge, must be based on algorithms and mathematical models that are nourished by data obtained with sophisticated systems for Earth and ocean observation. In this way, the recovery plan will not only improve the quality of life of citizens, but will also help create a large number of highly qualified jobs. The solution to challenges such as climate change or the proliferation of extreme weather events must be based on a good understanding of our environment and all its interrelationships. The combined study of ocean, atmosphere, and space, as well as their interactions, is essential to model our environment. We must be able to understand global, regional, or local phenomena, but at the same time, we must be able to understand mechanisms with response time of years, another that happens in a few seconds. For this challenge, it is comforting to hear today in this session presentation from the top leaders of organizations such as NASA, NOAA, European Space Agency, Mexican Space Agency, NSF, and NAS. As a final remark, before we leave the floor to our distinguished speakers, I would like to recall that during the next 4 days, we will delve in all those questions with plenary and parallel sessions with 70 speakers from around the world. It is our intention that the outcome of those presentation and discussion drive the definition of the Earth-centered missions for the next future, helping to better decide the main objectives of our international organization. For this reason, the contribution of all of you is of paramount importance to us. We are counting on you. Thank you.
Thank you, Miguel Belló. So our first presenter of this session is Craig McLean. Craig is the Assistant Administrator of Oceanic and Atmospheric Research at NOAA in the United States. Craig?
Yes, thank you. Tom, can you hear me?
I can.
Very good, sir. Thank you very much. Well, Tom and Miguel, thank you very much for the introduction. And I want to thank also the Air Center and Penn State for hosting such an event. It's a very important subject, and I commend you on the list of speakers that will follow. And I'll begin by offering an overview rather than any real detailed prescriptions. So if I can have the next slide, please. In looking at the situation we find ourselves in here with COVID-19 as a global pandemic impacting our economy and impacting the way we do business, it gives me pause to reflect on how did we get here? The next slide, please. Here is not necessarily the advent and onset of a global pandemic. Here is facing the global challenges that have been recognized already in the introduction that both Miguel and Tom have provided. Climate change is real. The elements of human causation are profoundly established and certainties. And how we respond to these challenges is up to us. I come from the National Oceanic and Atmospheric Administration, where I will continue to reaffirm for you that scientific integrity is the foundation of the information we need to communicate to the public. Communicating to the public is a challenge. There are so many mixed messages that are being proffered that we have to come back to the attraction to rely on science, not the convenience of momentary opinions. So in doing so, we have built a prosperity engine for the global economy, particularly in those developed countries, that are based on the developed technologies from the midpoint of the last century. And we have enjoyed that prosperity through products of convenience, and we have conveniently ignored the byproducts of that economy and that method of production. Those byproducts are today polluting our atmosphere, causing climate change, and impacting the ocean in manners that we are beginning to understand, but still don't fully understand. So where we need to go from here, next slide, please. We need to be monitoring the ocean and taking its vital signs. The ocean is the patient. And if it is the patient, we need the pulse, the respiration, the blood pressure of the patient. We do that through satellite observing. We do that with modeling that results from satellite observing. And we also do that with in situ measurements, as the Argo float that's being displayed here is routinely deployed with about 4,000 of these floats in the world's oceans. Still not enough. Now we move to the next. If the patient is the ocean, next slide, please. If the patient is the ocean, we have the pulse and respiration, but we still don't have the Gray's Anatomy of that patient. We need to understand through mapping, exploration, and characterization, where are the various elements inside the ocean, as the ocean is a driver of climate, a driver of weather, a source of food, and the ocean's rapid rate of change is very concerning. Next slide, please. Embedded in the ocean are many surprises for us, including the recent, I'll say relatively recent, discovery of, for example, the genus Pelagibacter, which is an organism that is ubiquitous. It is probably the smallest package of DNA in a microorganism, and its very important role is to break down the products and reintroduce into the environment those elements necessary for photosynthesis. We don't know yet how this organism, which our oxygen depends upon, will respond to, for example, ocean acidification. Next slide, please. There are many mysteries yet remaining in the ocean as to just species identification and role within the ecosystem. We have a long way to go. We can do this from space. We can do this from the ocean, and we must do both. Next slide, please. As we move from the ocean into the atmosphere, we can recognize the change in atmospheric greenhouse gases, where we are at the point now where we have more PCO2 in the atmosphere than we have over, well, since the Pliocene epoch. And given that we didn't have humans roaming the Earth in the Pliocene epoch, this should immediately be a concern to people who could rationalize these distinctions. So we're engaged in measuring the changes in our atmosphere and the abundance and changes of atmospheric greenhouse gases. This is something that we will be increasingly able to do with satellites. Currently today, we labor to do this from ship-based platforms and from gas samples at fixed observatories and many stations around the world. We need to get a handle on this. We need to understand where it's going in the future, because all of this, whether it's the knowledge of the ocean and the knowledge of the atmosphere, links to, let's have the next slide, please, how we conduct ourselves as a global society and global population. Food security is important for all countries, all nations, all regions. Yet many of the food sources that we enjoy are migrating latitudinally in response to, for example, climate change or overharvesting and depletion. Next slide, please. As we move into our commercial habits, imagine that this ship in this storm is uncrewed, and that will be upon us in the near-term future. How much do we know about meteorological forecasting and the degree of our certainty with the weather envelope that would constitute the duration of this voyage? We still have many science solutions that are necessary to be generated. Next slide, please. As we look from space and we realize that the ability of detection of various phenomena from satellite is increasing with the fidelity of the instruments and the abundance of satellites that give us new angles, literally new angles of approach, we come to learn much more about our planet, its behavior, and give us the ability to forecast it. Science will drive this renewed economic engine. Something like the UN Decade of Ocean Science, which you will hear more about shortly, is going to be very important to attain this. Next slide, please. As we look at the changes in the Earth and its behavior, we're seeing an increase in the number of, at least for in the United States, the number of billion-dollar-plus cost of impact from weather-related events. Over the time that I've been with NOAA, since it's roughly 1981, there have been over 273 individual billion-dollar-plus episodes. Please do not attribute that to my tenure at NOAA. I don't think I'm the causative agent. But in looking at that timescale, it's astounding to me that that constitutes roughly $1.8 trillion of economic loss to just one nation, and extrapolate that to the many nations around the world. This changing Earth is concerning, and our adaptation and recovery from the global pandemic has to include methods of resilience. Next slide, please. Here's just an indicator with the bright red line to show what track we are on here for 2020, and it could be a similarly alarming and extended degree of loss. Next slide, please. So as I conclude, in restarting our engine, it can't be the engine that got us to here, because what got us here is an outdated engine. We need to be designing a society that has a circular economy, that has the ability to look at both products and byproducts and find uses for those byproducts, so that we could be certain of a future that our grandchildren would not just be proud of for our labors and efforts, but that they will inherently and completely rely upon. Thank you very much.
Thank you, Craig, for that excellent and compelling presentation. I think if we have any immediate questions, we can probably take them, but we're also going to have save some time for the panelists at the end of the session as well.
Thank you.
So I don't see any hands raised. By the way, if you do have immediate questions for follow-up for any of the speakers, please put your hand up in the participant level. Our next speaker is Terry Quinn, and Terry is the director of the Ocean Sciences for the National Science Foundation in the United States. And by the way, I should mention that all of the speakers' bios are up on the Air Center website, so I'm not giving the extended bios because that would take an awful lot of time, but these are really stellar individuals, and I want to thank all of them for participating. Terry, you're on.
Thank you, Tom. I think we're going to have, yeah, there we go, a slide put up for me. Thank you. Well, it's always, it's great to be here. Thank you for inviting me. It's always tough to follow Craig. So I've given up on that in terms of the eloquence of his presentations. So I'm going to go with a single slide kind of approach today for that. So again, I'm going to try to talk today about the NSF investment in the blue workforce and provide a few examples of where NSF science investments align with themes in this summit. So let me start with a few words of introduction. The Division of Ocean Sciences is one of the 4 units in the Geoscience Directorate at NSF. The Geodirectorate provides roughly 64% of the federal funding for basic research in the geosciences at academic institutions in America. Our division, Division of Ocean Sciences, had a budget of more than $365 million last year. We made 337 awards. But as we all know, and one of the reasons we are meeting virtually today, that in 2020 was like no other. The year 2020 was like no other in the history of the academic research enterprise due to the COVID-19 pandemic. The leadership team at NSF recognizes that the ongoing pandemic has on the academic research enterprise. We recognize the impacts of the pandemic are often disparate. We acknowledge that widening differences in access to electronic and in-person resources have the potential to deepen longstanding inequities faced by students of color, disability, or from areas lacking reliable and fast internet connections. Women in particular continue to be disproportionately affected by the change to the virtual environment and dependent care becoming a full-time job. Some universities have instituted hiring freezes and furloughs. During this period of academic duress, we must take direct actions that support all members of our community, but especially students, postdoctoral scholars, and early career scientists. NSF is committed to supporting our workforce, and there are a number of opportunities for building a blue workforce in a post-pandemic world. We have the next slide, so should be a word come up. There you go. So let me start then transition to investing in the inclusive blue workforce. NSF is committed to training the next generation of ocean scientists and engineers and ensuring that the ocean science and technology workforce is diverse and inclusive. Let me provide a few quick examples. The Division of Ocean Sciences recently released a Dear Colleague letter informing our community that we will start a postdoctoral research fellowship program early next year. These programs have a long history of serving as launching pads for successful careers of faculty members, research scientists, engineers, entrepreneurs, and innovators. By investing in our postdocs, we are investing in the future and are enabling the blue workforce to renew itself and expand. We also need to give our students training opportunities early, often, and throughout their careers. We fund programs like STEM Seas, which provides a ship-based 10-day exploratory experience for undergraduates from diverse backgrounds aboard NSF-funded ships. Such experiences are important for inspiring the next generation by providing them with a seagoing introduction to the ocean sciences. We also fund a large number of research opportunities for undergraduate students through our Research Experience for Undergraduate Sites programs, or REU. Students work closely with faculty to develop a research project and learn the skills they will need to pursue a career in science. A robust blue economy requires a diverse blue workforce, and NSF continues to invest in the education and research opportunities. We at NSF and OCE also need to ensure that the research and educational environment is just, equitable, diverse, and inclusive. Our academic enterprise must also be free from harassment that has plagued our field in the past. In 2018, NSF released Important Notice 144 on harassment, stating that NSF does not tolerate sexual harassment or any kind of harassment within the agency, at grantee organizations, field sites, or anywhere NSF-funded science and education are conducted. In 2020, we made an award to the American Geophysical Union and partners to help combat sexual harassment in the geosciences. The project team aims to improve workplace climate and increase gender parity in earth and marine sciences. In summary, NSF is committed to helping foster an inclusive STEM literate blue workforce that is prepared for the future, that creates new knowledge and innovations that best harness the benefits from our scientific discoveries. Now let me transition to a few examples of where NSF investments in science align with some of the themes and sessions in the summit. Next slide, please. Let's start with coastal resiliency. A few years ago, NSF sought ways to advance understanding of the impacts of coastal environmental variability and natural hazards on populated coastal regions, which led to the development of a new program called Coastlines and People, or COPE. COPE is supporting coastal research hubs to work at the nexus between coastal sustainability, human dimensions, and coastal processes to transform understanding of interactions among natural, human-built, and social systems in coastal populated environments. The goals of COPE are synergistic with the sessions on day 2 of this summit titled Resilience to Coastal Natural Hazards, which includes presentations on extreme weather, flooding, sea level rise, and coastal erosion. Next slide, please. Now let's move on to ocean observation, something that Craig mentioned. The creation of new knowledge in the ocean sciences is often facilitated by technological advancements that allow ocean scientists to observe, to measure, and model critical ocean variables at new spatial and temporal scales. This notion dovetails nicely with session on day 5 of the summit called Improved Environmental Maritime Monitoring, which includes presentations on numerical modeling and marine robotics. A key aspect of ocean observations is making the data readily available to the broad community of stakeholders through a user-friendly web-based interface. The Ocean Sciences Division supports the Ocean Observatories Initiative, aka OOI, with an annual budget of nearly $44 million. OOI is a science-driven ocean observing network that delivers real-time data from more than 800 instruments to address critical science questions regarding the world's oceans. Data collected by OOI is open access and near real time. Imagine the possibilities if the blue workforce doesn't have to be on the coast, but students and researchers from landlocked states and nations can fully immerse in and contribute to the ocean research enterprise. NSF also funds observations in some of the most extreme places on the Earth through, for example, the Navigating a New Arctic program. NSF supported the Mosaic mission, which launched in September 2019. The mission froze in an icebreaker in the Arctic Ocean to better understand this remote region and the role it plays in global climate and weather patterns. The Mosaic expedition is one of the most ambitious international Arctic field missions NSF has ever funded. The long-standing observational gaps that this mission is filling promise major advances in our ability to understand the current state and likely future trajectory of the Arctic. Next slide, please. Now let me finish with some comments on convergence. NSF is sponsoring a series of workshops to accelerate the convergence between academic, industry, government agencies, and foundations. The NSF Convergence Accelerator's mission is to address national-scale societal challenges through use-inspired convergence research. One terrific and timely example of this concept is the Future of Oceans Innovation, Exploration, and Utilization Workshop, which is being held this week. This NSF-supported workshop, organized by MIT and the Woods Hole Oceanographic Institution, will explore ongoing challenges and emerging opportunities in the future of oceans. And lastly, I would like to draw your attention to an NSF-funded study, Advancing a Systems Approach to Studying the Earth, a strategy for the National Science Foundation. This study is being conducted by the U.S. National Academies and will develop a compelling vision for a systems approach to studying the Earth and identify facilities, infrastructure, coordinating mechanisms, computing, and workforce development needed to support that vision. A final report is expected to NSF in the spring of next year. So let me finish where I started by thanking the organizer of the summit for inviting me to provide an NSF perspective on global challenges and local action in a post-pandemic world. Thank you very much, and I very much look forward to other presentations in this session and some Q&A later. Thank you.
Excellent. Thank you very much, Terry. Again, I'm just checking the panelist, the participant list to see if there are any hands up for immediate questions, but it looks like people are willing to wait until the discussion at the end there, Terry. Thank you very much. Our next speaker is Jan Wörner, the Director General of the European Space Agency. And looks like, Jan, your slides are ready to go.
Yes, I am. Hello, thank you very much for inviting me also to contribute to this very interesting discussion. And I will go in a little bit different way to the topic. So first of all, we have a lot of global challenges. We all know that. I will not go through the list, but we are talking here about maritime aspects, about the sea, etc. And of course, all of what is listed here comes also to the sea. But there is another challenge, and we all know it. It's this coronavirus. And this coronavirus is changing the world, not only because of the health issues, but especially also because of a totally different aspect. And this is the digital transformation. Suddenly, many institutions have to understand that digital transformation is necessary. And for me, this digital transformation is also an opportunity to go to new roles, to go to new space, to go to new structures. I call it synaptic structures, to go to more performance orientation, to go to new processes and new opportunities. And that means that especially digitalization and artificial intelligence will be more important in the future than ever before. And this is, as I said, this is, of course, an opportunity. Digital transformation is a global opportunity. We can suddenly be linked worldwide even better than ever before, because this will now also the normal day by day. But of course, there's also some digital divide, and we should take care that not the digital transformation makes the gap even bigger between poor and rich and so on. So therefore, this is also a challenge for all of us. Now I will give you some examples also, especially with regard to economy, what can be done and where we are. So one thing is artificial intelligence. We launched a small satellite with artificial intelligence. So this is just the first and very first example. So in this case, the satellite does not take photos, images of all what it can see, but defines and decides by itself, by artificial intelligence, whether to take a picture or not. In this case, it was with respect to clouds. But based on all of these innovations and both the Earth observation, we can look to the future, and that means we can have a digital twin Earth, which covers not only Earth observation, but also navigation, telecommunication, exploration, science, and technology, to have something really like a twin of the Earth, which is good, especially also for simulation and for forecasting what will happen on the seas, but also on land. And therefore, in this respect, we are looking also, of course, to the Blue Worlds, which is an ESA initiative internally, and we are now moving it to become an ESA program to really go ahead and ask also our member states to support that. And what can be the part of it, the contents of it? One is, of course, autonomous shipping, where we are really going for autonomous operation and ship intelligence, where we are taking big data analytics for optimization and decision processes, and there we also go for more and more innovation. This is, in general terms, the autonomous shipping from harbor to harbor. But especially the auto-docking for the harbors is also something which will change business, because this is really something which is needed. And in more general terms, the autonomous supply chain from production to the final user is something we should develop. And in this respect, as I said earlier, with all these autonomous marine activities, it's a combination of satellite navigation, satellite communication, and Earth observation. And I show you now just a few examples what can be done. This is, for instance, using the automatic identification system, which normally the ships have on board. And by that, we can really identify where the ships are. And this is important, especially if you compare it with Earth observation data, because then you can understand that whether a ship is really a normal ship with sound automatic identification system, or whether you have a hijacked ship where it is different. We can also see concerning the environmental impact of ships, for instance, the NO2 emission. You see here, if you look exactly to this, you see, for instance, from Europe to the United States of America, these lines where you have more NO2 concentration because of the ships, and also in other areas of the world. Concerning Portugal, we are very happy that we could create an ESA lab on the Azores, which is now dealing with many things, for instance, also to develop Earth observation technologies for environmental monitoring of ports and Earth observation application for ports and Atlantic cities. So this is very special instruments we are developing. So what is all about, what is necessary for all of these examples is, of course, communication. Communication sounds, first of all, as a very trivial thing, and each and every one has some keywords for it, for instance, also 5G. But there's another aspect. If we want to really trust communication for our ships and use satellite navigation and all these data, then we have to see that there is an issue of cybersecurity and cyber safety. Normally people are talking about cybersecurity only, but I will show you in a second that it's also about cyber safety, not only security. So what we need is secure data storage, because the different actors should have access to the right data. It should be secure data transfer, but also if we are using it for navigation and other purposes, there should be a secured real-time communication and a secured data processing. And there is a tiny thing which can disturb us, and this is solar flares, because solar flares can really have direct influence of all these aspects. So it is not a security issue, it's for sure a safety issue. So it can directly have an impact on our spacecraft. It can have also an impact on the surface of the Earth for all of this. And we are right now together with NASA looking forward to have a space weather forecast system also with NOAA, so that we can in the future really tell people, be aware there is some solar flare coming. Unfortunately, not days in advance, but so far it might be only 15 hours or 1 day. But this will be a very big help in order to have a more safe application for all these maritime applications. And finally, what is very important for me is, yes, competition is a driver. We need that day by day. But cooperation is an enabler, and therefore I'm very happy that I could participate and can participate in this conference, because this is all about cooperation. Thank you very much.
Thank you very much, Jan, and I appreciate that final message very much. So I'm not seeing any media questions for Jan, but we will have a discussion at the end of the panel, and I appreciate all the panelists keeping to time as well, so we're moving ahead nicely. The next speaker is Salvador Landeros, the Director General of the Mexican Space Agency. And Salvador, I think everything's set, so please go ahead. Salvador, I think you're still on mute. I might be able to change that.
He's muted. You're muted, Salvador. You're muted.
I've just, oh,
okay.
Try, yes, try again. There we go.
Sorry.
Okay, thank you. All
Thank you.
Good now.
Okay, I am pleased on behalf of the Mexican Space Agency, the invitation submitted by our friend Miguel Belló, CEO of the Air Center, to this panel on global challenges and local action for the All Atlantic Summit, kindly organized by the Air Center, Penn State University, and AECEDA. It's an honor to share this session with a distinguished group of panelists. The contribution of science, technology, and innovation in times of crisis from coronavirus disease, SARS-CoV-2, COVID-19, is key to addressing current health challenges, but also to support the productivity efforts of the post-pandemic economic recovery era. Space economies from every country cannot get behind this effort, and must sum to the blue economies, which are substantial for the coordination and recovery of this crisis. From oceans and coasts, fisheries, air observation, for marine operation to plankton, aerosols and cloud interactions in ocean ecosystems, to secure food sustainability, we need to learn from space. That crisis and disaster resilience is part of our scientific DNA, and that we can contribute to fight economic, health, or resource crisis of any kind, including post-COVID-19 activities generating employment in each single opportunity behind it. Water resource management, climate prediction for meteorological associated risk events, sustainable seaport management and biodiversity, and ecosystem sustainability are part of the Earth and space science actions and objectives that support the 2030 Agenda for Sustainable Development Goals. Nevertheless, to preserve the sustainable use of oceans, seas, and marine resources, to offer these kind of solutions, we need to study many different issues, such as their temperature, chemistry, CO2 concentration, marine currents, and life. Our rainwater, drinking water, weather, climate, coastlines, much of our food, and even the oxygen in the air we breathe are all ultimately provided and regulated by the sea. During the Conference on Science, Innovation, and Information Technology on the 7th of May this year, held by the Executive Secretary of the Economic Commission for Latin America and the Caribbean, CELAC, ministers, deputy ministers, and senior leaders of ministries and governing bodies of various governments in the region agree that post-COVID-19 activities will signify a magnificent challenge in every single step of the productivity change reaction of the economy, and that a common vision should be needed to assist each country population, particularly for people living in the coast communities who represent 30% of the global population. We cannot forget that oceans provide livelihoods and tourism economic benefits, as well as subsistence and income, but they also help to regulate the global ecosystem by absorbing heat and carbon dioxide, CO2, from the atmosphere and protecting coastal areas from flooding and erosion. In fact, coastal and marine resources alone contribute an estimate 28 trillions of the global economy each year through ecosystem services. So what is the common vision in Latin America and the Caribbean in post-COVID-19 supported by space? Well, space science application is vast, and each single crisis also represents an opportunity. So I would like to address them. To address them. First of all, it's clear that the post-COVID-19 will not return to normal soon. So, like any ill patient in the world itself needs monitoring. Every single country in the world needs to monitor the transportation access through their coastal limits to secure that people and goods are not in danger. First, because population can get contagious from the first point of access. And second, because any goods, staples, or resources coming from the ocean needs to guarantee a full benefits to the incoming nation. This is why I would like to emphasize the importance of the participation of Mexico through the Mexican Space Agency in collaboration with China. In collaboration with China, I moved this China, EUMETSAT, and the United States NOAA in the GeoNetCast, a Geo Foundation task and an integral part of the GEOS Commune Infrastructure, GCI, for generating and deliver a wide range of Earth observation satellite data and products. So what kind of space technology can help us to support recovery from this? Those that provide economic recovery, such as space monitoring to recompose supply chains, apply data science for regional integration in coastal and integrate ocean observation system, weather observation and forecasting to those that support strategic sector, such as tourism and holiday vacation, with a secure and calculated social distance. In Mexico, it's clear that Latin America must address a common view on COVID-19 impact at a time of slow economic growth. There is an economic paralysis that will result in a sharp recession of minus 5.3% of the GDP. In addition, trade plummets will drop by at least minus 15% in the value of exports, and unemployment rises by 3.4% with an additional 12 million unemployed people, with an increased poverty in 30 million people, which will represent an unprecedented challenges in the region. But opportunities are there. Space economists alone can guarantee. One, that in 10 years, increment in the use of satellite imagery, not only for ocean studies and science, but for other economic productivity. Sectors like agriculture, finance, and energy will increase in 30% in the use of business analytics. Second, that the startup creation in the space field industry will increase exponentially, as it has been doing it since 2010 at a pace of 15% a year. Three, that marine, aerial, and ground internet communication will move to a new space segment in a completely new industry for near around $10,000 million. Fourth, and that not only cell phones will compete for services in the GNSS geolocation market, but the million of the IoT devices that will interconnect in the new space economy of services for health, security, international telework, and e-learning services. So it is mandatory to the region to reflect on the economic effects that such changes will have in Latin America and the Caribbean markets. From the Mexican Space Agency, we foresee two different effects that can be real. Direct effects measured in the responsiveness of our health system, which can be overwhelmed with the second wave of COVID-19 contagions, and this is why it's mandatory to control coastal access to the country in terms of vessels and cargo ships from an epidemiological perspective. Indirect effects, which will be impact in the contraction of global demand and supply chains, such as food security and sustainable fisheries. Containment measures and impacts on blue economy employment are needed, then to be addressed directly from the space economy perspective, but also responses in the region should be on health, social, fiscal, and monetary measures. How space science and technology can help to address these issues? The digital space science ecosystem, particularly in data processing infrastructure, is an area of opportunity, considering that Mexico and the whole Latin American region have the longest longitude of coast in the world, and the future cooling system for data center technology rely on coastal cooling system. Data and information processing have demonstrated the most suitable and necessary resources to offer solution in a timely manner to challenges such as COVID-19 vaccine studies. The physical space science ecosystem, particularly in space science infrastructure such as air observation and monitoring satellites for weather, coastal and ocean analysis, for example, the extent and duration of harmful algal blooms in the ocean, or even the potential benefit of such vegetation system for new pharmaceutical applications. The contribution of space science technology and innovation to COVID-19 is vast in its challenges, but also many of its secondary and derivative applications have a direct impact in health and economical productivity activities such as follows. Those that maintain or resume activity, such as teleworking, telehealth protocols, and supply chain management and transportation, included those performing in any ocean and coastal extension. New business digital models that rely on satellite communications, such as giving access to services in remote location or disaster recovery areas. Those that support companies such as satellite connectivity to support financial activities, such as lines of credit, refinancing, tax relief, etc. Air observation to support health, private, and governmental services in the effect and correlation and comorbidity populations to climate change effects in the geographical regions where they were settled. Those that produce critical inputs locally, such as satellite connectivity to support factory conversion and developing new capabilities. Air observation, air observation to support health, private, and governmental services in the effect and correlation of comorbidity population to climate change affect the geographical region where they were settled. Those to produce critical inputs locally, such as satellite connectivity, support factory conversion, and developing new capabilities. Air observation for aquaculture, water resources management, and fisheries, same as for measuring the correlated effects of water chemistry in relation with water consumption and comorbidities. Satellite connectivity to support the recomposed supply chains, regional integration, and strategic sectors.
Salvador, we're a bit over time. Are you almost wrapping it here?
Yes, I almost finishing.
Thank you.
Satellite observation for monitoring transportation mobility, population displacement, vector-related interaction diseases in coastal population, as well as health georeference vaccination campaigns will help of health and tele-assisted epidemiological vigilance systems such as SATCOM, air observation, and GNSS, multi-space agency collaboration in health space science for COVID-19. Industrial and technological policies are required then to enable the region to strengthen productivity capacity in the space economy and generate new strategic sectors. To impact the new global economy, the region must move towards new space technology and its derivative for greater innovation, productivity, commercial, and technology integration. In Latin America, a market of 650 million inhabitants would be a major insurance against shocks generated outside the region. I would like to mention that we have an ongoing plan with the European Space Agency to support our efforts in detection of illegal fishing, for which I thank personally my peer, John Wörner, but would like to sum this and many efforts to support of my peers in this table. The National Oceanic and Atmospheric Administration, Kaye McLean, with whom we are already collaborating with NOAA in the Coastal Observation and Application Study teams in CEOs, focusing in users driving value chains that have targeted discussion on priority cost observation and applications such as calibration validation for Mexico's coastal and ocean coverage. AM would like to participate in the CEO's coast pilots location, and which we are planning to potentiate through the already established GEO's Blue Planet initial collaboration. Just to conclude, I would like to thank Jack Kaye from NASA and Larry Meyer, Chair of the Ocean Studies Board at National Academy of Science, because of Mexican Space Agency, we are already collaborating through the PACE Ocean Science Initiative, which provide data for future NASA AMM joint research opportunities in air observation process. We would like to make formal and extensive thing. Ocean conservation should not stall ignored as we face the COVID-19 pandemic. We must seek long-term solution for the health of our planet. Our lives depend on it. The pandemic provides an opportunity to revive the oceans and start building a sustainable blue ocean economy. Employment is just a natural deployment of a healthy system called health. We just must study and preserve it for the future generations. Space is part of our future. We are part of the future of space. Thank you very much.
Thank you, Salvador, for those detailed and helpful comments. We have two more speakers. Jack Kaye is next. Jack is the Associate Director for Research in the Earth Sciences Division of NASA. And Jack, please take it away. I did want to mention, as he's getting his slides on, that those of you who are participants, I may be given some misinformation before. So if you do have questions, the route to that is to post them as a comment on the live stream, and then they'll be routed to me. And I do have a follow-up question for all the panelists, so we'll have that for a discussion. Jack, you there?
I'm here. Can you hear me and see me? I'm having trouble getting the share screen to work, so I'll give myself 1 minute.
Yeah, I can see you, or I can hear you at least, and here it comes. Got it. Okay.
Yeah. If you can hear me and if you can see me, see the charts, then it may be less important that you see me. And in part, it may be a feature of the browser version of Zoom that you can't see me and my charts at the same time. So I'll plow ahead and want to start out by just reminding folks that what we do in Earth Sciences at NASA is to look at the Earth in an integrated system, but we do it in an end-to-end way that can start with a very fundamental technology, but building and launching flying things, doing research, and making the connection to how that can really help people in terms of products and services. If one actually thinks about the way we look at the Earth as an integrated system, we talk about 6 interdisciplinary science focus areas. And if you look at the way that we describe them, you won't see oceans as a dedicated subject. But if you actually look at what's in those areas in the yellow text, the oceans are really everywhere, which is a reflection of the fact that the oceans contribute to and respond to global change, both naturally occurring and human-induced. Of course, when you think about satellites and 70% of the surface being occupied by oceans, satellites will provide a lot of opportunities to look at the oceans. And if you look at the fleet of satellites that we have, this is a busy chart with lots of abbreviations and acronyms, but around the Earth, sort of going in the counterclockwise from about 3 o'clock, you can see the operating satellites in sort of blue and green, the ones that we're working on in purple and yellow, space station instruments and technology CubeSats, and see that there's quite a few things that we are using to study the Earth. And if you ask yourself the question of which ones contribute primarily or significantly to the oceans as one of their objectives, and you can argue about the way that I drew this. Solid boxes for the ones that have oceans as a primary focus, dashed lines for ones that's a secondary focus. You can see it's an awful lot of them. So the oceans do represent an important part of what we do in terms of studying the Earth. And you know, recognizing one of the things that since we've been doing this for a long time, working together with our domestic and international partners, you start piecing together multi-instrument, multi-platform data records, and you can look over time, you can look globally and see how the oceans are changing and understand why they're changing. So this is a sea surface altimetry that we've done with a variety of partners and look at not just the total change, but we can begin to try to partition the change between how much is due to warming and how much is due to increased liquid water due to melting ice. All of this really through interagency and international partnerships. And one looks ahead and sees a lot of new things that we're going to continue to do so that the data that we freely and openly share becomes available to the global community for science and applications purposes. So the next launch, together with our partners in Europe and NOAA, is Sentinel-6 microfirelect, November 10th. So that's a week from Saturday, is the first of two of the next generation ocean altimeters. Then additionally, with international partners, the SWAT for doing high resolution ocean altimetry, as well as inland hydrology, and PACE, where we've got one instrument from the Netherlands on there as well for looking at the living ocean and what's in the atmospheric column above it, because we have to do the two of them together. So lots of new information that's going to be made available to let us ask new questions as we study the Earth in new ways. We also do things from the surface and from air, and you won't necessarily hear NASA talking about airborne stuff that often, but I thought it was worth using some of the time to talk about some of the things that we've done and some of the things that we're going to do, because I think it's really exciting, and it helps. The airborne work also can help bridge the scales between the global satellites, global scale of the satellites, and the more local and regional things that one wants, especially when one's getting towards needing to know how we can help people better live on this planet. For studying coral reefs, we did the coral campaign where we flew over lots of areas, mainly in the Pacific, to get optical imagery of coral reefs to understand how they respond to forcing. In a totally different way, and in a different part of the world, in the North Atlantic, the North Atlantic Aerosols and Marine Ecosystem Study looked at the sort of biology and biogeochemistry in the upper ocean, and then connected that to what's in the overlying atmosphere, especially in terms of biogenic aerosols and what they do to clouds and radiation budgets. So we integrated ships and planes as well as overlying satellite observations. And we're working on towards we hope, the second installment of the exports campaign, which is a largely ship-based campaign, but brings in data from overlying satellites. So we did one campaign in the northeastern Pacific. The next one, we hope to be able to do the North Atlantic this year to really try to understand the vertical flux of carbon in the upper ocean and what happens there. So in part to get when we're looking at ocean biology from above, we've got to know what's going on in the upper ocean as well. So we're looking to do that. And two other campaigns we're looking to do, Delta X, for studying the river deltas. In this case, we'll be doing the Mississippi River with radars and hyperspectral sensors, and we'll hope to do that one. COVID doesn't make field work any easier. And ESMOD for studying smaller scale, sub-mesoscale ocean eddies, what that means for vertical exchange in climate and biological variables, again, with a mix of remote sensing and using planes and ships and thinking about what that means for future satellites. And we hope to be able to do that next year as well. And we had a decadal survey that came out in late 2017, early 2018, and they had a variety of observations that it said that we should do. It didn't tell us what missions to do. It told us what kind of observations to do. We're doing studies on the designated observables at the top left. There were a class called Explorers and Incubation, and then some other things that they said were important, but they didn't put in the others, and I just colored boxes around those things that are relevant to oceans. So as we think about the future, oceans are a big part of it. I mentioned an applications program that really serves as the flexible bridge that connects all of what we do in flight and research and technology to those who provide products and services and have direct interfaces with those who need to make decisions, whether it's sort of dealing with hazards or policy development or resource management or regulatory development. And while oceans is not an explicit theme of any of the areas in applied sciences, again, as it is for research, there's really no part of the program that doesn't have things that are directly relevant to oceans, and I added some text in red to show that. And it's a real reminder of the fact that when we think about how we the information that we provide and the knowledge that we gain can help make a difference in people's lives. The oceans are really important, both in terms of coasts, I'll come back to that, and for things like the oceans as part of the food chain and security and transport and recreation and all of these other things that we know. Our Applied Sciences program has an effort in the towards the Sustainable Development Goals, and for this purposes, SDG 14, life below water. There's really the sense of, all right, how can we help with the unique information that we bring and the leverage by the partnerships that we develop to implement that. And things like marine biodiversity, the geobond is an area, and one can see working its way from some of the more fundamental work through the CEOS may coordinate through marine bond and working its way towards the Sustainable Development Goals and IPBES. Sea level change, I started with as an example. I'll kind of close with that. We have a sea level change activity that we recently selected. As a research agency, we solicit and select competitive research. But when we think about sea level change, we have to think about the warming of the ocean, thermal expansion. We think about melting ice. We think about changing gravitational forcing, especially as ice melts. We think about coastal subsidence and what that may do. And we bring all those pieces together and also try to make the data as easily available. So we have a sea level change portal that if you look at and you can see, you get some rolled up information, and the things that come into it, but you also get a sense of some of the specific things, especially that help you connect the changes in ice mass at high latitudes and what's going on globally with the oceans. And by way of conclusion, just reminder, the role of space, but recognize we never want to think of it as space versus other technologies. We also want to recognize that we can't do any of this by ourselves. And in fact, most of the things that we do involve interagency and international partnerships, and that we recognize that part of what we do is to learn about the Earth in a very fundamental way. An important part of what we do is to make sure that that information is available, accessible, usable, and used so that we can help improve the quality of life for citizens all over the world. And I'll stop there. Thank you.
Thank you, Jack, for that very excellent presentation and a great closing note as well. The last speaker of our panel here is Larry Mayer, who's professor and director of the Center for Coastal and Ocean Mapping at the University of New Hampshire, and he's joining us also in his role as chair of the Ocean Studies Board of the National Academy of Sciences here in the United States. Larry?
Thank you, Tom. Can you see my screen?
Yes.
Great. Okay. Well, thank you, and thank the Air Center for hosting this very important conference. Unlike my colleagues on the panel, I do not represent a funding agency, nor do I represent a federal science agency of any sort. I just represent an organization that's designed to call upon the best scientists in the nation and offer unbiased, evidence-based advice and guidance to the funding agencies or others who seek it. And I've been asked to fill you in on some of the activities of the National Academies Ocean Studies Board that are relevant to the blue economy, and I'm happy to do that. I should also mention that in my role as the chair of the Ocean Studies Board, I also serve as the chair of the newly formed U.S. National Committee for the Decade of Ocean Science for Sustainable Development. And I think this role of the Ocean Studies Board will be particularly relevant to our discussions. So let me start by just telling you a bit about the academies. They were started some time ago during the Civil War by President Lincoln, who was being deluged by inventors offering him all sorts of things that would help him win the war. And he needed unbiased input, and he chartered the establishment of the Academy as a private, nonprofit entity that could be called upon by the government for advice. It's made up of about 60 boards divided into 7 units across many fields of science, engineering, and medicine. And except for a permanent staff, the boards are really all made up of volunteers. So with a mandate to provide independent, objective advice to inform policy with evidence, spark progress and innovation, and confront challenging issues for the benefit of society. Again, numerous study boards, the Ocean Studies Board being one of them, many others, with representatives from academia, from NGOs, and industry with expertise in a particular broad area. What the boards do is they can initiate studies on their own, but most often they respond to requests for studies from Congress, federal agencies, or others. And once a study is decided upon, a study committee is selected with really experts in the particular area of the study, but most importantly, folks who lack any conflict of interest. And again, they're all volunteers. At the end of the day, the study produces a very highly reviewed report. It includes most often findings and recommendation. That report is reported back to whoever sponsored it and to anybody else. But most importantly, it's published and broadly distributed by the National Academy Press. As I said, the Ocean Study Board is one of those boards. It has a focus on ocean research, infrastructure, technology, and policy issues. It has a permanent subcommittee on fisheries. It's the U.S. National Committee to SCORE. And as I mentioned, it's just become the U.S. National Committee for the Decade of Ocean Science for Sustainable Development. Let's look at some recently completed studies that are relevant to the blue economy. And I've just selected a few here. This is over the last few years. There's been an ongoing effort to look at sustaining ocean observation, something very relevant to what we've heard about already today, to understand future changes in Earth climate. There was a report about that, and you can download any of these reports. That's been followed up very recently, just a month or so ago, with a workshop that really delved even further into the issues raised there. Another workshop on Atlantic offshore renewable energy development and fisheries, and a series of reports on a research review and decision framework for interventions to increase the persistence and resilience of coral reefs, next generation Earth system prediction strategies for subseasonal to seasonal forecasts, evaluating the effectiveness of fish stock rebuilding plans in the U.S., and a report that I actually chaired, an ecosystem services approach to assessing the impacts of Deepwater Horizon oil spill in the Gulf of Mexico. As you see, none of these had a specific blue economy mandate, but all are extremely relevant to the blue economy in their look at the trade-offs and balances between development, exploitation, and sustainability. If we look at some of the studies that are ongoing now, studies that are in progress, you see again that same real relevance to blue economy issues. 2 studies focusing on fisheries, one on recreational fisheries and one on mixed use fisheries. And I think we all recognize the tremendous contribution of fisheries to the economy. A study on understanding the ecological effects of offshore wind energy development, and that will be reported out soon in a special issue of Oceanography magazine. And a remarkable series of studies that started back in 1975 on oil in the sea, looking at the input, fates, and effects. And so there was a 1975 study. It was followed up by another study in 85. and a 2003 study. And as we did the Deepwater Horizon study, we fell back upon this 2003 study constantly. It was a tremendous resource, but we also realized that it was outdated, and particularly in light of the Deepwater Horizon experience, many of the lessons learned there, a new study is now ongoing that will update those issues. As we look to the future, the area I believe the Ocean Study Board may play its most important role with respect to the blue economy is in its role as the U.S. Committee for the Decade of Ocean Science. That's one study I forgot, which is an ongoing study now on oxygen CO2 reduction, ocean CO2 reduction and sequestration, which is a follow-up of a broader study on negative emission technologies and reliable restoration. So I mentioned the role that the Ocean Study Board is now going to play as the U.S. National Committee for the Decade of Ocean Science for Sustainable Development. And in this role, we will be a focal point for communications about the decade to the U.S. community. There'll be a website, newsletters. The website just came online a week or so ago. We'll be hosting a webinar in mid-October and a national meeting in January to really kick it off. The website is up here, but it's very long. Just type in Ocean Studies Board, U.S. Decade, you'll get there. So we play this communication role and an interface between the U.S. community and the decade structure. But most importantly, I think the role we're most excited about and probably most relevant to this discussion here is that what we'll be trying to do is really spark a community effort to promote transformative research concepts that could lead to really disruptive advances that will open up new avenues for ocean science and support of sustainable development. And we call these ocean shots, and there'll be a call for these, and we'll talk about those at our webinar and then at the kickoff meeting. And what we're looking for are really, really bold ideas. Craig McLean has given us that mandate to look for bold ideas that look for engagement from outside traditional ocean science fields, material science, biotech, nanotech, artificial intelligence, many of the things we heard in the panel today. And we're also looking for engagement of a diverse group of next generation scientists, technologists, and policy specialists, recognizing that we old folks are not going to be around maybe at the end of the decade, and it really has to be inherited by this new generation. And so I hope I have shown that the academies have and will continue to address issues that are relevant to the blue economy. These studies have, for the most part, looked at the balance between sustainability, development, and exploitation. But as we look to the future, it is clear that the oceans are really having a moment. I have never in my career seen so much focus on ocean activity, even in this time of the pandemic. In the US, we had a White House summit on science, ocean science and technology. A national strategy for ocean mapping, exploration, and characterization is being developed. We have the UN Decade internationally, BBNJ internationally, and a remarkable program called Seabed 2030, funded by the Nippon Foundation, which has this amazing aspirational goal of seeing the entire ocean mapped by the year 2030. These are all happening now, and all the things we've heard during the panel today are happening on national levels. It is really quite an exciting time. And what I hope is that with this new awareness, we are going to shift our emphasis from simply looking at the blue economy as a trade-off between development and sustainability, but recognize that sustainability in itself is an important driver of the economy. Marine sustainability efforts have a tremendous potential for creating new jobs and enhancing economic activity. And so I hope that we can seize this moment and look to a bright economic future driven by our quest for a healthy and sustainable ocean. Thank you, Tom.
Thank you, Larry. And thanks to all of the panelists for the very thoughtful and informative presentations. So we are running a little bit tight on time. I wanted to let the folks in the audience know that several of the questions that did come in, we're going to route to other sessions over the next few days, because they look like they're really targeted to those, whether it's water purification or education of the next generation. but I did want to ask for a closing question, and this will really be a lightning round. I'd like each of the panelists to just name one or two topics where they think that these opportunities for better alignment in the future of Earth observations to support the blue economy. What do you see as those best opportunities, and especially in the context of the Air Center, where these nations around the Atlantic can work together to make that difference? So I'm going to ask you to respond in the order that you spoke, starting with Craig McLean.
Thank you very much, Tom. I would recommend that for the Air Center to really establish and further a meaningful role in all of this is to be a convening authority, be a convening element. The uniqueness of the location is certainly profound, but there are many locations in and around the Atlantic that the North Atlantic Research Alliance or the Galway Statement has brought in unity. But I think the important thing is to emerge as a unifying component and an opportunity for people to meet and converse. We do it virtually now, but we also understand how much more meaningful in person these meetings can be. Thank you all very much.
Thank you, Craig. Terry Quinn.
Yeah, I would add to what Craig said, and basically, facilitate. There's lots of be the hub, and there's lots of spokes out there and doing various things, and so overlap. So if you can sort of get those spokes into the hub, I think that's a great space to be in. So facilitate that action.
We'll do it. Jan Wörner.
Yes, so the Air Center is for me and could be the institution to exchange information and to facilitate cooperation. That means also to share data, to share ideas, because we are the only one on this tiny planet. So we should really take care of it and not believe that there is a better place outside this Earth.
Thank you very much. The sentiment shared by all. Salvador Landeros. Salvador, you're on mute again, so we can't hear you.
I think that Air Center can contribute very well to the future of air observation and blue economy with some regional information satellite system, or having a constellation among different countries to support different regions. So that could be a very good opportunity and a very good project. Thank you.
Excellent, great suggestion. Jack Kaye, NASA.
I think that, as others said in terms of convening, but I think really helping to facilitate getting to all the right parties on both sides. So I think on our end, the hope is that if we're engaged, those in the countries don't need to worry about how to reach the different parts of NASA. We'll provide one-stop shopping. But similarly for those in the countries, it may be hard for us to figure out, who all the right players are in the agencies and entities and things. And so if it's again, the concept of one-stop shopping, then we know that we can, we don't have to try and figure out who the right people are. It'll all be obvious to each other.
Wonderful suggestion. Thank you very much, Jack. Larry Mayer.
Yeah, it's easy coming last because everybody has said all the good stuff. Ocean processes know no boundaries, and observing systems have to coordinate across the oceans. And I would hope that the Air Center could really be that focal point to coordinate those efforts so that what would appear, well, use the Atlantic as an example, it would be a truly Atlantic observing center. The other thing I would like to see the Air Center play a role in is the fact that for observations to be useful, they have to be sustained for a long time, kind of a different concept of sustainability. And this is a difficult thing. And I think, again, having a focal point that can coordinate many, many nations in trying to make commitments to sustaining those observations could be a crucial role that the Air Center could play.
Great point, Larry. Yes, we're in this for the long term, and we need to make sure the resources are there for the long term as well. All right, well, each of you has really done a wonderful and incredible job of sharing what your agencies are and what your own ideas are for the future, and I want to really thank you very much. You're also incredible nodes in this network, and I appreciate the comments about how we can maybe better coordinate and share and make those single points of contact to make things happen. So thank you very much for your participation today and for your participation in the future with the Air Center as it moves forward. Our final speaker for the day and with closing remarks will be Manuel Heitor, who is the Minister of Science, Technology, and Higher Education for Portugal. And Manuel, I thank you. You've spoken before, and I think we all know you now, but please go ahead. And as you're getting online, I just did want to mention, for those of you who had some internet problems today, these sessions are all being recorded and they'll be posted within about 24 hours of the original recording. So you can find them at the Air Center website. All right, Manuel, please.
Thank you very much, Tom, for the way you have shared this meeting. And first of all, let me thank you all the speakers for these excellent contributions. And in fact, if 3 years ago this could be a dream, now we clearly understand the role the Air Center can play in better understand how satellite data and space systems can be used for to better understand space, climate, oceans interactions. I should also acknowledge the unique contribution of the Air Center with the European Space Agency and with Wörner over the last year to set up an ESA lab at the Azores, which is within the Air Center, has been able to set the foundations for an Earth observation lab, as well as more and more the InCube platform, which is giving rise to the challenge of putting together an Atlantic constellation. Apart from these details, it is clear from the several presentations, either from the work described by Craig McLean from NOAA or Terry Quinn from NASA, certainly the work undergoing under the blue worlds of the European Space Agency, but also by Kaye and Larry Meyer, as well as Salvador Landeros, that we have a huge amount of information coming out from space systems. And actually, it's interesting to recognize which an amount of data emerging, how little we still know from climate, oceans, interactions. And I will make 2 points particularly. First is the role of Air Center is more and more to help people raising the best and the most difficult questions. We need more and more to use all this data in a knowledge-driven process to raise the most difficult questions, and that is where Air Center could definitely work to bringing together scientists, experts, local policymakers to identify the key questions we need to solve, making use of this enormous and emerging amount of data which is coming out year after year and in a very much exponential form. The second issue within this question of this issue of question making, we should always remember the increasing inequality arising and which is it's characterizing Atlantic regions from south to north, north to south. We live in an Atlantic ecosystem really where poverty coexists with very healthy societies. So the way we can better have this global understanding, and particularly help African societies from poverty in zones where food value chains are not enough powers to provide food to every single citizen, can definitely be an important issue for their center. I should note that next year in April, we will try to bring together all the African ministers engaged in space systems and technology to discuss the way where Earth observations can help certainly building up the economic or closing the information gaps and provide innovative services to foster an inclusive blue economy, particularly in Africa zones. And this could be certainly a game to be played by the DDR Center. But overall, although we have clearly listened about many applications of Earth observations, it was particularly important for me to listen to some of you addressing space weather. And we know that certainly providing a better environment for understanding space weather and its relation with planet weather will be an area of increasing relevance in the years to come. The examples provided by Greg McLean, Terry Quinn, or Ian Wörner were very, very precise in defining the broad range of space systems, including those associated with the emergence, or at least the need we need to foster and to promote to better understand space weather. And this could seem a vision, but this is our present daily life. Again, I will close by emphasizing that we live in unique times everywhere in the north and in the south, and the sanitary crisis that we live in with the COVID-19 pandemics, it shows, or it should be an alert to better understand the imbalance we live in between economic and human activities and the planet Earth. And if it is true that the pandemic has been caused or has passed from animals to humans as a reflection of that imbalance of human activity in the planet Earth, we can only better understand and go over the risks we live if we integrate space-related systems with in situ information. Again, after listening to all of you, and again, I thank you very much, the Air Center, to provide this unique session with the leading space agencies at the world level. I will definitely try to call the Air Center to drive the most difficult questions, and particularly to using this opportunity to better understand why we need to better understand the interactions between climate and oceans to provide a better quality of life in north and south, and in south and in north hemisphere. If the Atlantic do provide a field of experimentation, a field of making new and difficult questions, we are certainly providing hope for future generations, and that should definitely be our main goal. So let me thank you to all of you. Let me thank you, the Air Center, for organizing this unique session, and let me thank you, Tom, for sharing so well this brainstorming session. Thank you very much, all.
Thank you. Well, great summary of the afternoon or evening, depending on where you are. And I'm going to just turn it back to Greg Jenkins to wrap up and tell us what's next in the rest of the week.
All right. Thank you, Tom, and for all of the speakers of the last session. Very engaging. Today has been a pleasure for Penn State to host the 6th high-level dialogue. And also tomorrow we begin the thematic sessions. Before I leave, I'd like to really thank the joint team here at Penn State and at the Air Center for working so hard for many months to make this happen. And again, thank you, Minister Heitor, for your comments. So tomorrow we begin at 1300 UTC or GMT, 0900 EDT. We have a very exciting week ahead of us, and we look forward to your participation. Once again, thank everyone for their efforts and their participation today.